Hello, all, and welcome to the third session of SystemVerilog for verification short videos. Today, we will try to cover part 2 basic data types. In the last lecture, we went through the data type net and its subtypes. So, today, our agenda is going through variable and its subtypes like integer, real, void, class, string, event, user defined data types, and enumerations. Variable, it means a data storage element. It needs to remember or store its value until the next assignment. Let's start with the first data type, integer. Here we have a list of integer data types and having some properties. For an example, short int. It is having two state values, size is 16 bits, it is assigned data types, and its default value is 0. Here, two state and four state data types means two state data types having values 0 and 1, while four state data types having values 0, 1, x, and z. So, for an example, integer, it is a four state data type, size is 32 bits, it is signed having default value x. Now, if I talk about bit logic or reg, it's written that its size is user defined vector. What does it mean? It means a user can define its size. For an example, here logic 3 down to 0 ABCD means ABCD is a logic type variable having size 4 bits, 3 down to 0. So likewise, these all integers are having their default values and their properties. We will look at the declaration in our terminal. So let's come into the coding part. Here, in this integer example module, I would like to introduce some of these integer data types and we will try to look at the default values. So let's start. I'm declaring say short int a, then say int b, then byte c. You can look at this data types over here, then say integer t, and let's also consider one vector, so logic 3 down to 0 e. Okay, so we have declared different integer data types. Now let's display their default values. So I will begin one procedure, initial block. Inside that, one display statement having values a, b, c, d, and e. Right, let's compile this code using vcs-s verilog integer.sv and using /simv. Let's run it. So it's telling me that initial values are 0, 0, 0, x, and x. So a, b, c are having default values 0, while d and e are having default values x. We can verify it over here. So keep practicing with these data types and their values. Next data type is real. Real, if we are good with C, I will say real is equivalent data type of double and short real is equivalent data type of float. Means real is a 64 bits signed data type having default value 0. Similarly, short real. One more excited feature is $real time. In terminal, we will try to look at the difference between $time and $real time. Okay, so let's start with some new code of real time example. Here, I would like to uh, have one statement of time scale. This is a directive time scale 1 nanosecond by 10 picosecond. We all know this meaning of this statement from Verilog. This 1 nanosecond is a time unit, 10 picosecond is time precision. Now let's start some declaration, say logic value. Now what I want is to see the difference between $time and $real time. So I will start one procedure in which first of all let's write hash 1.55 value equals 0. So after 1.55 nanosecond, my value will be assigned to 0. And one more statement, save hash 1.55 again, value equals 1. Now I want to check the values. So I will write one statement, dollar monitor. This dollar monitor we are looking first time before we have worked with dollar display. So I will tell you in detail what does this mean. Say dollar real time equals dollar real time. Then after some tab, say time equals dollar time. Then okay, here I need one comma. Then my value equals say value. So what is difference between dollar monitor and dollar display is this dollar monitor will display this statement whenever any of the value inside that will change. So for an example, whenever this value is changing its value, dollar monitor will display the whole statement. So now let's compile and run this code of realtime.sv. Okay, it's compile clean or slash simv. Okay, so it's showing that at real time 0 time 0 my value is x, at real time 1.55 time 2 my value is 0, and real time 3.1 time 3 my value is 1. Now let's try to understand the difference. Because my time scale was 1 nanosecond by 10 picosecond, say 10 raised to minus 9 divided by 10 raised to minus 11, so 10 raised to 2. So my dollar real time will try to display the floating point number with two decimal point, and dollar time will having its integer value. Now I have given first of all after 1.55. So after 1.55 real time, I have got some value equal to 0. Okay, and after again 1.55, so summation will be 3.10. So after 3.1 my value is equal to 1. And what this dollar time is doing, it is rounding off this real time value. So 1.55 will be 2, and this 3.1 will be 3. So at 0 time I am having some default value, because logic has default value x. I am having here x, then value equal to 0 and 1 at given time. Okay, so my dollar real time and dollar time depends on my time scale. Here is some exercise time. Go through this exercise. First one is to play with set default values, and in second one we will go through all the integer data types having some assignment values. So go through this exercise, and if you have any doubt or confusion in the statement or in solution, do post into the comment area of video. Next data type is void. Void means simply non-existence of the data. What does it mean? For an example, if I have some function call and it's returning nothing, so whenever I just write function call, actually it means void equal to function call. And it is also one type of tagged union. This we'll look at later while we're covering union data type. Next data type is class. Oops, object-oriented programming starts here. We'll go through the class data types in depth in the next few sessions, but right now some overview that class contains properties and methods. For an example, I am having one class data. Here is end class. In between, I'm having some properties like bit ABC, logic 4 down to 0 CDF, some integer. I'm also having methods set task clean, which is cleaning all properties, end task, end class, and default value of class is null. So we'll go through all the class and oops concepts in some next sessions. Next data type is string. String is variable size, dynamically allocated array of bytes. What does it mean? It means that say string is a keyword. I am having string s0 equals hello world. Okay, so here each character is having a memory assignment of 8 bits or say byte. So my complete string is array of bytes and it is dynamically allocated because this hello world, it can be expanded using say some concatenation. For an example, here I have written s0 equal to concatenating s0 with new. So my new string is hello world new. So I can say that it is dynamically allocated array of bytes. We are having some operators for string. I have listed them here. You can look at them and can practice by your own. We won't go through each operator in detail because it's common to all languages. For an example, equality, comparison operator, concatenation, replication. Whenever I'm having say here three in brackets some string, so it will get replicated three times. Then indexing, we can have indexing of a string. For an example, here say s0 of 1 is e. Okay. And lastly, string dot method. So strings are having some method support and we'll go through them. These are the methods string is supporting. For an example, string dot length. It is returning the length of string. Similarly, put c, get c, two upper, two lower. You can go through the description over here and can try by your own also. We'll try to look at some example of string so that we can get familiar to it soon. Here in string example, what we'll do is let's take one string with string keyword, say s, and I'm assigning value in initial begin. So I'm having s equal to say hello. Okay. Then I want to display the string. So say display percentage s, which is used to display a string. After some tab, I am trying to display its length. So now what I'll do is first one is s and second one is s dot len function. Okay. Now I am concatenating a string. So concatenation operator s with new string, say world. Okay. Then I'm repeating this display statement here. And lastly, let's take one more example of method, say s dot to upper. Okay, and again displaying the same statement. So now let's compile and run this code. Let's compile clean. Now let's run this. So here I am having display hello with length 5, hello world with display 11, and now lastly two upper function. So hello world in uppercase having length 11. So likewise, we can use all these functions of string, and here I have given one exercise such that you can go through some of more functions. So go through this exercise once. Next data type is event data type. This is a tremendous feature of SystemVerilog because we can synchronize two or more processes actively here. What does it mean? Basically, let's say here is a declaration of event A. This is how I can trigger one event, and this is how I can wait for some event triggered. Let's go through example so we'll actually understand what does this event do. Okay, so here what I will do is I'll declare one event named A. Then let's have some logic variable B and C. And in one procedure, what I will do is I will assign value b equal to 0. Then after 10 nanosecond, let's take b equal to 1. After b is 1, I am triggering event A. Now in some parallel procedure, so one more block, initial begin, and here I'm assigning C variable value 1. Then now I'm waiting for event A to occur, and then my C should equal to 0. Okay. Now what I'll do is I will display the values of B and C so that we can see the difference. I'll use $monitor, which is more helpful when we want to display anything that gets changed while code is running. So B equal to percentage B, then also let's display C equal to percentage B, B and C. Okay. Now what I have done here is after some process, I am triggering event A. In some other process, I'm waiting for that event to get occurred, and after my C is equal to 0. Let's compile and run this code. After that, we'll try to understand what it's doing. Event.sv dot slash simv. So my display is at time 0, my B was 0 and C was 1. At time 10, B got 1 and C got value 0. So what happened at this time? At 10, B got value 1, event A got occurred. So here the statement got executed and my C is having value 0 that we can see here. Okay. So this is how event data type occurs. This is very useful when inside our test bench we have to wait for something to occur for what we are planning to do. Okay. So next data type is user defined data type. A keyword is typedef. A statement is like typedef, data type, and type identifier. Example, typedef int animal. This means now my animal is a new type which is equivalent to integer, say int. So now instead of int lion tiger, what I can say is animal lion tiger. So my lion and tiger are variable of type animal, which is my equivalent type of int. Why is this type def or say user defined type required? Because in code, many a times what happens is we are having int lion, int tiger, but we never know what it actually means to. So for just readability, we are using type def. Okay. Next is enumeration. Enumeration means a set of integral named constants. It means that, for an example, say enum red, yellow, green, light one. Here, light one is enum which is having values red, yellow, and green, where my first variable will be equal to 0. This will be having value 1 and next will be having value 2. Similarly, this statement say enum bit 1 down to 0, some values and state next. So state and next are having values idle s1 s2 where idle is having value 0, xx is having value x, s1 is having value 0 1 and s2 1 0. So you can go through various examples of enum. Let's consider also one more. Say medal is having value bronze equal to 3. So silver and gold will get values 4 and 5 equivalently. So here are also the answers. You can look at them. Here C. It will be having value just 7 plus 1 equals 8 here. We'll try to look at the example of enum here. So here, let's use a type def with enumerator. So we will have example of both. So what I will do is type def enum uh, values 1, 2, 3. The name of my type def is numbers Here I have defined one type, say numbers, which is equivalent to enumerator of 1, 2, 3, where 1 is having value 0. This is having value 1, this is having value 2, likewise. Now let's take some variable of type numbers. So my type is numbers and I'm taking one variable n1. Now let's start with some procedure. Initial begin. Here what I want to do is I want to use some of the enum methods. Enum is having methods like first, last. So we look at them. Here let's say n1 equals n1 dot first. So this is a method of enumerator n1 dot first. So it assigns this 1 to enum n1. Then I'm having a while loop while 1. So it's infinite loop. Then it's begin end. Then let's display the value first. Say enum numbers and n1 dot name. Here is another method n1 dot name which will display the names of my enumerators. Next, say if n1 equals n1 dot last, then I will like to break this infinite loop. Any infinite loop must be having break statement. And now say n1 equals n1 dot next. Okay, so what I have written here is firstly I am assigning first element of enum to n1. Then in infinite loop I am displaying its name, say 1, 2, 3. Then until I am having value n1 equal to n1 dot last, I am assigning n1 equal to n1 dot next. So whenever I am on 1, it will jump to the next element, say 2. And whenever it will be having last statement, say 3, it will put a break loop. So now let's run this example. Cs if enum.hv. Let's run it. So here it's displaying enum numbers 1, 2, and 3. So we'll also like to use this kind of enum methods to elaborate the enums. Okay. Here I have given one enum exercise where you need to design one sequence detector of say 1011 using state machine, and in state machine we will use our present state and next state as enum. Here is a hint like how we will write them and how we will use them. In Verilog we were used to work with parameters. Here instead enums will help a lot. So that's it for the variable data types. In the next session, we will try to go through parameter, then scope and lifetime of all these data types and casting, so that we can have casting of one type to another. So this is it for the current lecture. You can post any question in the comment or any confusion. Thanks for watching the video. We'll be having next session soon. Thank you.